Hey boys and girls, Mr. Sandoval here with homework video number 6 for week number 6 of the school year. And this one we're going to focus on energy, okay? We're talking a lot about motion and forces and energy, and we're going to specifically talk about energy and how that affects objects in motion, okay? And so get your journal ready, have that out, and make sure that you are checking Jupiter grades. And we're getting close to the end of quarter number 1, if you can believe it. Time is flying by. So check and make sure you're caught up on everything. Also, make sure you're organized. I know I've been checking around. A lot of you guys, you're losing papers. You can't find papers. It's because they're all mixed together and they're not organized. So keep your backpack, keep your folders organized. All right, again, so have your journal ready out in front of you. If you don't have it, get a piece of paper because you're going to jot down some notes and some answers and questions and answers today. All right, so remember we're talking about motion. So we've thrown around some terms like speed, distance and time, velocity, forces, which are pushes and pulls, right? Forces, we need a force to move objects, to move matter. Friction and gravity are examples of forces. They are pushes and pulls, and they require energy. To give a force, you need energy, okay? And the bigger the energy, the more the force. Gravity, acceleration, momentum. So these are words we've been talking about. And so we're going to focus on energy. And I want you to think about, what is energy? We throw that word a lot around, but what does it really mean when we're talking about it in science class? There's electrical, heat energy, chemical energy, atomic energy, potential, and kinetic. You may have heard these terms. Here's another graphic that shows sound can be energy, right? Sound can move things and shake things. Have you ever heard like a big speaker with bass, low bass or something? It can shake the windows in a car. Again, electrical energy like lightning, light, heat. These are all things that have energy, and for something to move, it needs energy. For something to do work, to do work, when you're doing work, you're actually moving. You're moving your muscles or something. You need energy. All matter has energy. Energy is needed to do work and to move matter. Okay. Another interesting way to think about energy is that energy can destroy or damage things. So if you're having trouble thinking about, does something have energy, could it do damage? Could it destroy something? Lightning, electrical energy, has a lot of energy. It could destroy this chimney, destroy a house, explode. Fire has a lot of energy. It can cause damage. These NASCARs going up to, close to 200 miles an hour or something, when they crash, like you see here, there's a lot of destruction, a lot of force. A lot of force is causing pieces and parts of the car to fly around. You see heat, you see sparks. So there's a lot of energy in this crash, in this pileup. This wrecking ball, right? When it gets moving and swinging, it has a lot of energy. It can smash through a brick wall. And then we know like nuclear energy, right, has a lot of power, a lot of potential to cause destruction. This is the Fukushima nuclear power plant in Japan, which a few years ago had an accident, and there was lots of energy released. Okay, so that's a good way to think of it. Energy can move around, right? Wind can move the wind turbines, which can create another form of electricity, another form of energy, electricity. And what causes the wind? The energy from the sun, heating up the land and heating up the air. Or the sun's energy can directly cause, in solar cells, we can convert that to electricity. Or you see the trees, they can convert the sun's energy into food, which is energy for organisms to use to live. So energy can move around and change forms. We get the energy that's stored in food. There's chemicals in the food that our body can use to turn into energy so that we can do work, so that we can run and play sports, as you see here. All right, and that kid, he's pretty into that pasta. So right now, write down in your own words, what is energy? Write down 2 ideas about what is energy, okay? Examples, definitions. Again, if you need to pause the video, you can do that. All right, so we're going to talk about 2 kinds of energy today, though: potential energy and kinetic energy. And I found a cool video of some astronauts while they're up in the space station giving us some examples of potential and kinetic energy. Okay, so think about those 2 words, potential and kinetic. You may have heard those before. So let's watch this video, and I will come back after it's done. It's just a couple minutes.
the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the fan and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So, when I have this ball on this ramp, normally back on Earth, I release the ball, and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So, it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast, and so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
All right, boys and girls. So right now, write down what you just learned about potential energy. What is potential energy and what is kinetic energy? And we'll talk about it a little bit more. Again, potential energy is the capacity, the kind of like stored energy, right? If you stretch a rubber band, you have potential in that rubber band, right? If you let it go, it's going to hurt if it hits you or something. A bow and arrow, you pull back, it has potential. If something is really high, it has a lot of potential. If you drop it, it has a lot of potential to do damage, right? Especially if it's a bigger object. Kinetic energy is the energy when something is moving, all right? So potential energy can become kinetic energy. Kinetic is the energy of something that's moving, right? Like those NASCARs going 200 miles an hour. They have a lot of kinetic energy when they're moving. All right. Now, when they're revving up at the start line and they're getting ready to go and they have a lot of fuel in the tank, but they haven't hit the gas yet, they have a lot of potential energy. Okay. So we're going to go through some examples. You can think about that. In your journal, number 1 to 5. I'm going to show you 5 scenarios, and I want you to think about potential energy or kinetic energy. All right. Okay. So number 1. I want you to write the answer to this. So when people go skiing, they take a ski lift all the way to the top of the mountain. So you can see on the right side here, all these people are way high up on a mountain getting ready to ski down the slopes, back down the mountain. Do they have here potential energy or kinetic energy? Write down your answer, okay? Think about that. Potential or kinetic energy when they're at the top of the ski slopes, getting ready to ski down. Okay. Number 2, now this father and son are skiing down. Do they have potential energy or kinetic energy? Are they showing potential or kinetic energy? Write down your answer. And then, second part 2 is who has more energy, do you think? The father or the child, the son? Which one of them has more of the energy that you selected? Okay, father or son. Number 3, these people are on a roller coaster. It looks like you can tell they're moving very fast. Is this an illustration of potential energy or kinetic energy? When you look at this picture, looks like fun. Okay, potential or kinetic, write that down. Write it down. Okay, number 4. This rock these rocks are totally balanced, and like it looks like they could topple over at any time. Is this an example of potential energy or kinetic energy? Okay. And part 2 of this question, which has more energy, the left or the right? So this, look at that little stone at the right here. Does this stone or this boulder have more potential or kinetic energy? Whichever energy you selected for your answer. Which has more of it, left or right? Okay. And one more. I want you to just do a quick sketch of this loop of death, right? Back to Tony Hawk. Label the arrows. There's 4 arrows. At each point, what does the skater have? Potential energy or kinetic energy? So when he's standing at the top of the ramp, getting ready, does he have potential or kinetic energy? Now he skates down the ramp and he's just about to hit the loop. Number 2, right there, label potential or kinetic energy. Now he's going all the way up and he's completely at the center, the top of the ramp, as high as he can go. Does he have potential or kinetic energy there? What does he have more of? And then he completes the loop, and at point 4 right here, okay, right here, he's exiting the ramp after coming down this part. Does he have potential or kinetic energy right there? All right. So you might need to pause and take some time to finish this diagram. All right. Okay. So what is energy? Write down what you think energy is. Write down potential versus kinetic energy, little definitions, and then you have your number 1 through 5 answers. Make sure you get that parent signature. All right. And thank you. Good job. We'll see you in class, and we're going to talk about this for sure. All right. So make sure you have those notes complete and neat, and work on that for a couple minutes right now. All right. Bye.